Let's get it on. What?
You probably really rehearsed it all in your head, huh?
No, that was all free base right there. All right, here we go. So we're gonna take this, and we're gonna bring it up. So take the derivative y prime. Do you remember? Find the derivative. We got to take this exponent, multiply it by the coefficient. 2 times 1? 2. And then...
Is it the 9?
And remember, we could write this as y prime or dy dx. Either one is the same, correct? Oh, that's not the same. Alright. But we're not... Oh, yeah. We are done, but we're not done. What happened to the 2? The 0 made it go away, right? Boom, we're done. Okay, next. Number 6. What do we have to do to this before we can actually do the derivative?
Bring the x up?
Yeah. So this is really a 1, right? But when we take this and bring it up, we turn this into negative 2x to the negative 1. Right? Okay? So that's really important. What's up?
I wrote it wrong. I wrote that.
Okay.
Wait.
Keep going.
Oh, wait. Well, we're on film.
Sorry.
No, that's cool.
I'm confused. Wait,
okay.
Wait, did you like solve it, number 6?
No,
oh, I wrote it wrong. Oh my god. Sorry.
Okay.
Gotta keep dropping.
Sorry.
It's plummeting.
I don't know which one I wrote down.
Alright, so what we did for number 6 is we had negative 2 over x, right? And so we had to rewrite that as negative 2 times x to the negative 1. Before we can even do the derivative. Because now when we do the derivative, we're going to say, hey, negative 1 times negative 2 is what?
2.
2, right? So y prime is equal to 2x, and then if I take 1 away from negative 1, what do I get?
Negative 2.
Negative 2. So 2x to the negative 2, right? But now, in order to write this correctly, I'm going to take this negative 2 and I'm going to bring it down, right? So then y prime is going to be equal to 2 over
X squared.
X squared. Good. Now this is simplified, and this is unsimplified. Cool. So I'm going to want to see both on a lot of these.
I'm confused.
It's on YouTube.
This one? You told me it wasn't.
Oh.
Oh no.
But right now we're worried about these. You're gonna get,
I already did that.
oh, okay. Just want to make sure.
So then, okay.
So walk us through this as you already did this. What am I going to do to this one?
You're the teacher.
Am I really? Come on now. What do I do?
Wait, for what? 7?
For,
Oh, fuck. Hold on, I gotta write that.
how do I rewrite it?
Wait, I already did it.
Wait.
3, or you have to...
Why would it be negative 2?
Yeah, that. Wait.
Under the
Why did I
What?
Because there's a negative?
Because there's a negative out front, right? So that would be 2 times that is negative 2, right?
Good.
But then the negative 1 times the negative 2 equals 2. Back. Back here? Okay. Back to the one you were saying, what? 3?
3x.
And x.
To the 1? Yeah. Negative 1, isn't it?
Yes. So we're taking this 1 and we're bringing it up and changing the sign.
Yeah. Where does negative come from?
Because the negative exponent takes it either down below or brings it up above. So by changing the sign, we take it from its position and put it in the other position. So, like, that's what we learned last year a lot, algebra, algebra 2, and then now we actually need to do it. So for calculus, we have to bring everything up to on one level so that we can deal with it. It's the easiest way to deal with it. Well, we can deal with this, but it's called the quotient rule, and believe me, when we get to the quotient rule, you'll thank me for teaching you how to do it without using the quotient rule. Okay? So yeah, if we just bring it up, boom, now we have a negative exponent, right? And so to take the derivative, we're going to take this exponent, multiply by the coefficient. So y prime is going to equal
-3.
-3.
Negative 3x to -2 or something.
Yes, to the -2. Because we subtracted 1 from a -1 and got -2. Cool?
How do you simplify it?
And now we simplify it. So we're going to take this -2 and bring it down, right?
Yeah.
And so that means that y prime is going to equal what?
-3, or